Hello, ladies and gentlemen. I have a sub today. I am observing another teacher at a different school, along with some other thing, trying to learn some Avid strategies for my Math 1 class. So let's go ahead and do this lesson. We have 13 slides, so we definitely need to get in. There's a lot to cover, and so I'm hoping today that that what I says makes sense and helps you do the homework while I am not there. Let's go ahead and get started. Antiderivatives. Instead of giving you a function and asking you to find a derivative, what would you do if you were given a derivative and asked to find what the original function was? For example, if I have a derivative, f prime of x is equal to 3x squared, and I were to tell you to find f of x, think about this problem. Substitute teacher, when they are ready, you can press play. Otherwise, press pause to give them time to think. The pause button is the enter button on the doc cam. Coming back. So what I'm hoping you noticed is you hopefully got x to the third. I'm hoping what you did, instead of multiplying by whatever number that you had, normally we would multiply when we're finding a derivative. We're doing the opposite of that. We're doing the antiderivative. We added 1, we went up, and so instead of multiplying, we divided by 2 plus 1, which is 3. 3 divided by 3 is 1, and x to the third. So this is one possible original function. This is one possible antiderivative. Could be more than this, by the way. This is an antiderivative. This is one possibility of this derivative. This is a way to find the original function when given a derivative, and that is called an antiderivative. But let me just talk to you about what other possibilities there were. So I could have done this one, x to the third plus 2. I could have also done this one, x to the third plus 10, or I could have done x to the third plus pi. If you had these as your original function, what are the derivatives of the following? What's the derivative of this one? And what's the derivative of this one? And what's the derivative of this one? So if these three things are the derivative, if they all have the same derivative, then that means if you're starting with a derivative and you're going up a level, doing an antiderivative, that there are more than one possibilities. C is going to represent a constant in our problems. This is a constant. This is a constant. This is a constant. When we take a constant's derivative, it generally goes away. But if we're doing an antiderivative, we're going to have to denote that there could be a constant that's added to this function that we have to take into account. So all three of these have the same derivative. All three of these have the derivative of 3x squared. It doesn't matter that those constants are different. This means that our previous answer was only one possible antiderivative, but not the only antiderivative. To find all the antiderivatives, which is called the general solution, you must use a constant of integration, which is we're going to use as the variable c, to take into account all possible solutions. This is called indefinite integration, and we use an integral sign. This symbol right here, it looks like an S, has a little curve to it, means we're taking the antiderivative of 3x squared, and the dx stands for with respect to x. Now, if I'm taking the antiderivative of 3x squared with respect to x, what that means is that I'm going up a level. I'm going to figure out if this is the derivative, what's the original function. That's what that means. And so I go up a level. Instead of multiplying by 2, I'm going to add 1 to this, which is 3, and then I'm going to divide by the 2 plus 1, which is 3, and that becomes x to the third. The only thing that I need to make sure I add is this plus c, because I have to keep in mind that the constant, when you take the derivative of that constant, will go away, so we don't know what that constant of integration is unless we actually have 1 point on the line. If we have 1 point on the line, we can then figure out what c is, which we'll get into later on as we get into here. Right now, what I need you to know, to find all the solutions whenever you're taking an antiderivative or the integral of something, you always add this plus c. It's like that extra little step that you have to do to get full credit on the test. So that brings us to the rule. And the rule is the integral of this is called indefinite integration, but this means the integral of x to the nth power with respect to x is we add 1 to whatever the degree is of n, and then what we do is we divide by n plus 1, because that is the opposite of what we were doing before with the power rule. Think of this as the anti-power rule. And we have to have this constant of integration so we know what all the possibilities are, where n cannot equal -1. You need to memorize the formula. You'll be using it often as we do problems. Now, this is where I give you, like Mr. Paramo's, this little hint, basically. It is helpful to pretend that the integral of dx is a positive c. It's not really, that's not what it really is. It's not what it represents. But when I do a problem, if I'm doing this and I follow this formula, I just kind of try to remember that the integral of this thing right here is plus c, which it's not, but it helps me to remember to add the constant of integration when I'm taking an indefinite integral. So that's my helpful hint for you. Whenever you're working a problem like this, if you see and you do this part and you do get that, don't forget that you still need to take the indefinite integral of dx and just try to pretend that the indefinite integral of that is a positive c. Okay? There you go. So let's do a problem. Okay? Here's our first example, and this example you can't do by yourself yet because I haven't really shown you how to do it. I'm going to tell you that the derivative of y with respect to time, dy over dt, is equal to 4t to the third power. And I'm going to take the integral of that. I'm taking the integral of this equation. I got a whole equation here. So what I'm going to do is I'm going to first, let's get some things by themselves. Let's get dy by itself. Let's first multiply by d over t, by dt to both sides. So if I multiply by d over t, then what I can do is I can take the indefinite integral of this side, and I can take the indefinite integral of the right side. When I do that, here is what I get. If this is the derivative of y, think of that as y prime. If I go up a level, what does that become? And then on this side, if I'm using this rule, you add 1 to the 3, and then you divide by. So what are you going to get? Don't forget to take the integral of this dt, which is not really, but we're going to pretend it is. And this is what we get. Y is equal to t to the fourth plus c. This answer has a y in it because we integrated dy over dt. The integral of this derivative with respect to time is y equals. It has to be in terms of y and time. Keep that in mind. I know I have this in here because last year some people missed a point on the test because they didn't put y equals in their answer when they integrated dy over dt. Hint, 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 you won't hopefully make that same mistake. Let's try another one. This time, I'm going to give you some time to work on it, and you can work on it by yourself or with a person sitting next to you. Make sure you and your partner both agree as to what the answer is. Substitute teacher, please pause and give them time. When they are done, press the enter key to press play again. And coming back, so now what we hopefully have, we did our work. I'm hoping you got x squared minus x to the third plus c. If you need help with that, here's my work for it. I added 1 to the exponent, there was already an invisible 1 there, and then you divide by that same amount, which reduces to x squared for that piece, and that reduces to negative x to the third for that piece. Okay, moving forward. Just like the power rule, we had to follow certain rules to use the power rule. I'm going to say the same thing goes for indefinite integration. There are limits to it. Indefinite integration, you have to have variables in the numerator, just like the power rule. You can't have any products of variables, just like the power rule on derivatives. Just like that, no quotients of variables, no exponents outside of parentheses. If we had these situations, we would have to use some rules like product rules and power rules and things like that for integration. Now the good news is there isn't any, so we're not going to memorize those in Unit 4. What we're going to do in Unit 4 is we're going to do the workarounds. You have to get really good at working around and making things fit these parameters. Work around them by simplifying before integrating. So let's make sure that we're simplifying and then we're doing the indefinite integral. So if I look at this, variables have to be in the numerator. Well, what happens if you have integration in the numerator? Well, that's in the denominator. You're going to have to move it up. How do you move it up? Hopefully you know it's using a negative exponent. So you move it up first. And then what? Now it's in the numerator. Can I use the rule? Yes, you can. Add 1 to this. And then divide by that amount. Divide by the negative 2 plus 1. Hopefully you know what that is. And then you're going to get this result, but don't forget you cannot leave your answer with negative exponents. You still have to put your answer in the denominator if you have a negative exponent as well. Use negative exponents to push it up, but once you take the indefinite integral, let me see if this will let me write here. Whoa! Pretty crazy. Touch screens are amazing. X to the negative 1 power, and we're dividing it by negative 1. So you have to adjust to this and scoot that down. What happened to negative 1? I just put the negative in front. Same thing. Okay. Next one. What happens if there's a product, Mr. Paramo? Well, in our previous example, you can't use the product rule. There is no product rule for integration. So how do I work around it? Distribute and simplify it first. So let me give you some time. Substitute's going to pause the video by pressing enter. You guys get to work on it. When you guys are done, press enter again to play. Now that you're done, here's what we have. We have x squared minus 4x to the third, and then we're going to take the integration of it. We're going to add an exponent, divide by that same amount, minus, add an exponent, divide by the same amount, and what we get is x to the third over 3 minus x to the fourth plus c. That's not too bad. I think that's pretty good. I'm going to adjust this screen just a little bit. Hopefully that lines up with how it presses play over there. So then what happens if there's a quotient? There is no quotient rule. and I have variable divided by a variable, there's a variable in the denominator, so you're going to have to move it up. But if you move it up, there's still a product. So keep in mind, this is in parentheses. So let me start you on the first step for something like this. The first step that I would do, I would treat this and scoot it up using negative x to the negative 1/2 power. This is in a group because I have the whole group divided by this root x. So that group is still a group. And so this x to the negative 1/2 is going to have to distribute into here. Oh, wow, look at that. Never done that before. Apologize, ladies and gentlemen. This is one of the first times I use the touchscreen computer. There you go. And so I have this. And when you multiply two things with the same base, what do you have to do with their exponents? I hope you remember. It's going to be a fraction. Don't freak out. 2.5 is 5/2, I think it is. And then the other one will be to the positive 1/2. Let's see. There we go. It's easier to do it with fractions sometimes. Now let's take the integral. And remember, we're adding 1 to each one. When you add 1 to 5/2, you get, I'm hoping you said 7/2. And when you add 1 to this, you get 2/2. When you do that, you're dividing by 7/2. You're dividing by 3/2. Let me remind you what happens when you divide by a fraction. If you divide by a fraction, you're really multiplying by its reciprocal. You can't leave your answer like this. You're not allowed to leave answer with no complex fractions. So you have to multiply by the reciprocal. If you're dividing by 7/2, the shortcut says you just multiply by 2/7. So I have 2x to the 7/2, 2x to the 7/2 power over 7 minus 4x to the 3/2 power over 3 plus the constant of integration c. I'm hoping that's not too bad for you because like this is a solid medium level problem. This is right in the middle of difficulty. It's not your easiest one. It's not your hardest one. If you can handle this, you know, we're halfway through this thing. This is good stuff. Here's one for you to try. Let me give you a minute to substitute to press pause as you get going. Now that you are back and ready to go over the answer, let's see. I changed mine to x to the 1/2 power. I moved this up. And only that up, the 2 stays in the denominator. And then I'm going to add 2/2 to each one of these things. And then divide by that same amount. Instead of dividing by 3/2, I multiplied by 2/3. That's my shortcut. Instead of dividing by 1/2, which I do this time because 2, half of 2, that's going to make it reduce. And don't forget the integral of dx, we're going to pretend is the constant of integration. There you go. Good job for those of you who got it. I'm hoping it worked out for the majority of you. And now the fun stuff Mr. Promo promised you back in Unit 2. I said if you don't remember your derivatives of trig functions, now you got to work backwards. You know what the derivative of sine is. I hope you do. The derivative of sine is cosine. But that's not what I'm asking here. What's the antiderivative of sine? If I take the derivative of what would give me sine of x? Well, the derivative of cosine is negative sine. So I can't get sine from the derivative of cosine unless I throw in a negative. It's so important for you to still go back and remember all 6 of your trig functions and their derivatives. If you don't know it, you didn't know it then, I still encourage you to memorize them because now we're doing the opposite. This one will be easier. Think about it. No need to pause. the integral of cosine with respect to x is, and I already know some of you just said sine of x, yay, but you're forgetting that extra point that I told you that students missed last year. What are the extra point? What are you forgetting? And I know some of you forgot this plus c. Don't forget it. Now let's do a little bit, let's get some tricky. The integral of negative cosine of x. The derivative of sine is cosine. Okay, the derivative of cosine is negative sine. So how can I get this as my derivative if there's a negative involved? Sometimes you can even think about moving that negative out in front of the integral if you want to. You can. The derivative of negative sine is negative cosine. So I'm hoping you see that. Let's do this. Let's do our last one, I believe, is right here for sine and cosine. The integral of negative sine of x. And the derivative of cosine of x is negative sine. So if I think about the derivative and what is the derivative, that's how I do it. It's going to be up to you how you decide. Let's take a moment right here and let's have the substitute pause the video, and anybody who doesn't get this and who needs someone to show it to them, let's get them a chance to partner up and discuss it, and then we'll pick up the video in just a moment. So please pause. Coming back. Now let's go further. The integral of 3 sine of x minus 2 cosine of x with respect to x. We're not just multiplying anything other than we have with respect to x. So the integral of sine of x, I could even use that right now to think about what it is. The integral of negative cosine of x, I kind of know what that's going to be. I'm going to do this one for you. Negative 3 cosine of x minus 2 sine of x plus c. That makes sense to me. If anybody has questions on it or needs an explanation, they can get it from a partner if you need. So now that you know how to find antiderivatives, now that you know how to do the integral of things, let's go a little bit further and now talk about the graphs of these things. Earlier, in previous problems, we gave you graphs of derivatives. Here's a derivative. This is the graph of the slope of the original function. It lets me know whether the original function has a slope that's positive, that's negative, and or 0. For example, this value here is positive values. So everything on this side of this line right here, these values that are right there, means that it has a positive slope on f of x, on the original function. These values, since they're negative, that means that there are negative slopes on the original function. And these values, since those are positive, they have a positive slope on the original function. What that means is this. I know that the left side of here, I have a slope that is increasing, increasing, increasing until it gets to this point where it's 0, and then it levels off, and I have a relative maximum. Then, after that, we have a negative slope. It starts going downward until we get to here where the slope is now 0 again, and then the slope becomes positive. So I can automatically know what the graph of a derivative or an antiderivative looks like. Here's my derivative, here's my antiderivative. But remember, it's plus c. It could be any constant of integration. So you cannot figure out how high up this is. It could be higher, it could be higher, it could be lower. It doesn't, we don't know where it is until we have one point that's on the line. Anywhere the derivative is equal to 0, is where a relative extrema exists on f of x. So if this is the derivative where this is equal to 0, that's a point of relative extrema. A max or a min is there on the original function, on its antiderivative. I'm hoping that that makes sense to you. So here's a function. I'm going to take the antiderivative of that, and let's do that together. Add an exponent, divide by 3, add an exponent, divide by the same one, divide by 1, and in a constant of integration, there's our function. Now let me graph a possible thing. It could be this one if c was 0. It could be if c was 1, if c was 2, if c was 3, if c was 4, if c was 5, if c was negative 1. These are all the possibilities, not even all of them. Those are all the possibilities where c is equal to a nice whole number. I didn't even pick one that's a fraction or anything like that. It could be any of those possibilities. What this tells you is, if you have a derivative, there are an infinite number of functions that could be the original function. We know what the slopes are like, but we don't know where they are. We don't know how high up or how far down that they are, unless we know one point on the function. So if we have 1 point on the function, you can solve for a particular solution. We're going to figure out, let's find 1 point and let's figure out what c is, and I'm going to show you what I mean. If I know that my function goes through 2, 4, 2, 1, 2, 3, 4, and I'm trying to figure out, is it the orange one, the purple one, the green one, which one it is? If you know this, then what you can do is you can actually use it to figure out what c is. You have an x, you have a y value, you just have to solve for c. Let me show you what it looks like. You take this x value, let me circle it, and you plug it in where the x value is, up here and up there. So if I put that there, I know it should equal an output. I'm going to put a y right there and say it should equal this output of 4. So instead of this, I'm going to put a 4 and plug the 2 and the 2, and I don't know what c is, so that's my work. Now I can figure out what c is, because 2 to the third is 8 minus 2, 6. What does c have to be? If I know it goes through this, I can figure out what c is. As long as I know 1 point on the line, on the derivative, or on the original function only, then I can find what the constant of integration is. Which means my new function, or my function, is now this one with the constant of integration plugged in. Let me have you see if you can try that. You can work on this with a partner if you would like. Here's your derivative. There is no graph for you. And I want you to find what is the constant of integration, what's the original function. That's what this means, by the way. Solve the differential equation. That means figure out what the original function is with c plugged in. Go ahead and pause the video. That way students can work on this together. Okay, coming back. Let's go ahead and work this one out. So I'm going to take the integral of this derivative of f prime of s. So I'm going to then, it's with respect to s, and so I'm going to add 1 to this exponent, so it makes it a 2. Divided by 2, I get 3. I add 1 to this, which is 4. Divided by 4, I get 2. And then I have this constant of integration. So if I know that my function is this, but I have a value on it The 2 goes in place of the s's, and it should equal a value of 4. So I'm going to replace this piece here with 4, and I'm going to replace the s's with 2. Order of operations, that's 4 times 3, 12. 16 times 2, negative 32. And I can work it out, do the math, and you're going to get that c is equal to 24. When I plug that back in, here is my new function. And that's how we solve the differential equation. What happens if you're given an antiderivative, a second derivative is this, and you have 1 point on the first derivative, and you have 1 point on the on the original function? Can you find all three things? Can you figure out what your derivative is? Can you figure out what your original function is? I bet you can. Go ahead and try this. I'm going to end this video because I'm at 31 minutes, and I'll start another video here to break it up.